the presentation from my end. I hope everybody would be able to see it.
Yes, we can.
Yes, thanks. So, hello everyone. As Maria introduced, I am Breach, and thank you all for joining us today on our webinar on breaking the silos. Different knowledge areas are needed to advance geothermal system and understanding by Lisl Lewis from GeothermEx, SLB New Energies. Before we start, I want to quickly give a short introduction of Lisl. So Lisl is a member of the EAGE London chapter, and she has a master's in electromagnetic geophysics from the San Diego State University. She has worked in academia, research, the mining industry, the hydrocarbon industry, and now she is in the geothermal industry. In her career, that has spanned over 25 years, and out of which 20 were with Schlumberger. Lisl is now doing business development and project management from GeothermEx, the geothermal consulting service arm of Schlumberger, and she works on geothermal projects globally. So again, thank you, Lisl, for accepting our request and joining us today to give a very good webinar. And before we go to the technical session, I would like to give you a short introduction about our young professional community. So the agenda for today, that I will start with a short introduction, then we will go to the technical part, then we will have a question and answer, and then we will close this webinar, all which will account for nearly 1 hour. So the young professional special interest community is one of the 2 special interest community on behalf of EAGE. And it is a network of young professionals who are aged less than 35 and who are interested in sharing and discussing advices on career development, work opportunity, and the skills that you need for a successful career. We are established in 2013, and now we are approximately 2,500 members on our LinkedIn page. So if you have not joined us, I welcome you all to please come and contact. Although you see that the age is officially 35 and less, but we want everybody to be there who can help us in reaching those goals. Let me give you a short introduction to our committee members. So I am currently chairing the young professional community. We have Carrie Holloway from Schlumberger, and also Ruth Shikpo. They are based in UK and Germany. Then we have Jonathan Stein from US. We have Sahyo from UK. Shihwan as well from Heriot-Watt University in UK. Then Yuri, who was the previous chair. Then we have Happiness from France, and then Aditya from India. So we are at the moment 10 people. And some of the activities that we do under the young professional community is the major one is a special session that we held during our annual meetings. Then we also participate in the EAGE mentoring program in collaboration with the EAGE special interest community on women in geoscience and engineering. We are quite interested in educational and networking events and collaborations. Such one is what you are attending today as a young professional webinar series. We help and provide news related to the industry, give career advice, and many times if we are aware of some of the vacancies to our friends. So a little bit on the EAGE mentoring program. So this is a 1-year career development program in which we match mentees and mentors based on their goals and preferences. So as a participant, you have access to advices on career and professional development. You have career transitions. If you are looking for switching your fields from industry to academia or academia to industry, if you want some advice on the work-life balance, technical and soft skills improvement. And the good thing about the program is that it's not very strict. We have made it as fluid as we can, because You can make your own pace of engagement. You are very free to interact with your mentee as you want, how you want, and you can decide what is the timeline that you want to achieve those goals. And I request that if you are interested, if you find it interested, please join us as a mentor or a mentee. In case you have questions, please reach out to us. We will be very happy to assist you. And this is for a small description of the mentoring program for this year. So we have quite a healthy representation of almost all the continents. We have participants as mentors and mentees from all the places. But if you will see this diagram on the right, that as I was mentioning, that half of the participation is from students and young professionals, but we also have mid-career professionals and senior professionals. So we are really open to everybody who would like to participate. As an upcoming activity, if you are planning to be in Oslo for the annual meeting for this year's young professional special session, we have a plenum session actually this year on the topic attracting and retaining talent. So if you are there, please join us on the Thursday, 13th of June, from 11:45 to 12:45. We have a very, very good panel this year who will be talking about all the new opportunities which we see that have a quite a good quite a good transition in terms of industry. So this is something which we are looking forward to. And also related to today's topic, we also have GET 2024 on the geothermal energy. You can still submit abstract. The deadline is 30th of June. So probably this would be a really good opportunity. And with this, I end my part, and I again want to thank all of you for joining us today for our webinar series. And I hand over now to Lisl for the technical part of the webinar today. Thank you all.
All right. Can you hear me and see my screen?
Yes, we can.
Okay, super. Thank you so much for inviting me to speak here and for this opportunity to meet the young professionals community that's new for me. So yeah, I'll just dive in. In fact, I decided to change the name of the title of the presentation because we don't need or want to break the silos. We need to link the silos because silos represent deep subject matter expertise and knowledge and nuance. And they're important. We don't want to break it up. So they also represent, have their own vocabulary, language, acronyms, language, so it's not that easy to interface. So anyway, why do we want to advance geothermal systems anyway? It's because we need to decarbonize. So the realities of climate change are upon us, and the energy transition is happening. And in order to meet our net zero climate ambitions, we have to do everything we can. We need all hands on deck, as they say, offshore. Geothermal is one of the oldest new energies, and it has an important part to play. So, in fact, I'll take the moment to just point out that the decarbonization curve, including sequestering carbon, that's what the plan looks like. And Schlumberger, when it was rebranded to be SLB, felt so strongly about being able to deliver new energy to the energy transition, it became part of the logo. So a little fun fact about that. So we're going to step through this agenda. bit of business context and bit of geothermal and tectonics and system types, and then get into the kind of meat of the presentation around silos and adjacent sectors, and go from there. So first, just a very quick bit about SLB. It's an energy technology company developing new technology to help decarbonize the planet. And we specialize in subsurface characterization. There are pockets of geothermal expertise kind of sprinkled throughout the entire company, but there's two separate business lines, let's say, that are dedicated to, 100% geothermal, and that's GeothermEx and Celsius. And so GeothermEx is a company that Schlumberger bought in 2010, so 14 years ago, and really left alone. Now things are changing. We're in a new era now than we were 14 years ago, and so I'm seeing that things are evolving. Celsius, I'm not going to talk too much about that in this slide deck, but it's a startup company that was created by 3 Schlumberger employees that is focusing on building level or shallow geothermal solutions, which is really cool. They're taking over the world. No, not really. But so just about GeothermEx, it's one of the oldest geothermal consulting companies in the world, and traditionally working along ring of fire, volcanic, steamy ground places in the world. That's represented by the little red dots on this map. But now we're seeing that we're moving to different geologic settings. Not just this year, it's been going on for some years now, but we're moving away from those traditional geothermal settings and seeing how we can access geothermal energy elsewhere. So that's represented really by the white and the blue dots on here. So and it's kind of buried in amongst the dots, but here's a little legend of what that means. So that's the sort of business context for coming here. Going back to just geothermal, we probably all know it means earth heat. And you can see on this map the plate boundaries. The core of the earth is radioactively decaying, and that decay causes upward flux of heat towards the surface. The average temperature gradient on Earth is about 25 degrees C, or some people say 30, with a corresponding heat flow of 60 to 65 milliwatts per meter squared. But the point of this map is to point out that at the plate boundaries, that's where the heat flow is higher. And so that's why geothermal projects have gone to those areas. And so we normally refer to them as the conventional geothermal or hydrothermal projects. So now we're looking at, moving away from those boundaries. So here's a little slide that just takes you through different types of geothermal systems. So even though it's one word, geothermal, it actually has come to mean so many different things. And like starting with the geothermal probe field, that's, in fact, you can even see that they're kind of in the shape of a pyramid. That is representing the Celsius solution, like the shallow geothermal, no deeper than 250 meters, that type of thing that can be used for heating and cooling a building. And then on the other side, you have the steamy ground tectonic plate boundaries, where quite often there's magma fairly close to the surface and resulting in volcanoes, and so tapping that in order to generate power has been kind of the main way that geothermal has been used. So these different terminologies are not fixed. You'll hear different. The terminology is a bit variable within the geothermal sector, but and I don't want to go too much into detail, but just to kind of show the different types of geologic settings and some of the names that have been given to them. So advanced geothermal system or closed loop is that, and then this enhanced geothermal system, EGS. The difference there is you're interacting with the geology here, whereas here you're keeping everything within the pipes. And you can see that these are drawn within kind of a homogeneous geothermal, or sorry, geologic setting, mainly to indicate that it's meant to be geology agnostic and or thereabouts, and it's really all about the technology and getting that to work well. Over here you have the world of sedimentary basin, which has not historically been treated as hot, and this is also a frontier. So there's other types of configurations besides what's drawn here. So this is just mainly to illustrate what we're talking about with geothermal. So that's that. But if we want to talk about how to progress the geothermal system understanding, then it's helpful to stand back and look at kind of the simplest way of understanding the Earth. And first of all, recognize that actually there's two heat sources. There's the core that's radioactively decaying, but there's also the sun. And the goal is to tap into that geothermal energy in the most efficient, productive, sustainable, economic way. But in order to do that, you have to really understand what are the ingredients. So you definitely need heat, fluid, and transport. You need to transport the fluids up to where you can access them. And so understanding or kind of standing back and looking at the Earth in this simplistic block model way, you can kind of draw different, make different sense of it, starting at the surface. And even from the surface of the Earth, where it's sunny, and well, in some places it's sunny and raining, and the water's coming down and interacting with the soil and the fractures and getting into the shallow subsurface, the meteoric water, and all that. That's we'll call that the biosphere. These numbers, I say biosphere less than a kilometer depth, geosphere greater than a kilometer. I don't know if that's really true. I think it's just kind of a ballpark way of differentiating the different processes that are happening on Earth. But when we want to stand back and look at geothermal, we can make that grouping of the biosphere and the geosphere, and also think about how do we image and how do we interrogate. So, and the point of doing all this is to be able to take each of those kind of as their own thing and look at what are the frontiers in that area and what does that have to do with geothermal. So this is where we're going to take a little tour of these adjacent sectors of environmental hydrology, chemistry, mining and minerals, hydrocarbon, oil, gas, and then other. Because when we think about the decarbonization challenge, we don't even really know what contributions will be needed. And new topics of study may well get invented if we only had the cross-pollination. And so I find this topic really interesting because I guess because I've kind of dipped my foot in a lot of these different sectors, and I've always been surprised at just the kind of complete misunderstanding or lack of awareness of what's possible or what's the frontier of these other sectors. So it's just really a powerful concept if we can find a way of linking, not breaking the silos. So first, just diving into the biosphere, you know, here we're talking about the meteoric processes and the, you know, the water, and that includes also the like civil engineering, environmental impact, kind of assessments and studies, and the whole world of environmental science really has a lot of deep knowledge and experience with water, with weathering and erosion, and even going into the biosphere, well, I said biosphere, but the world of biology, in terms of the microbial world, the interactions of microbes and organic sediments, geological materials. In fact, even there's a field of biogeophysics that evolved from doing field work, where the researchers were doing some geophysics over a contaminated hydrocarbon site on a military base, and they were expecting a particular result, and they were surprised at the, you know, electrical signature that they were getting. And so in kind of digging into that, it turned out that the hydrocarbon degrading microbes were producing CO2, and those were basically leaching ions from the sediments into the groundwater, and that was causing a different geophysical response when they measured it. So so then it has turned into a whole nother kind of field of study. And I think that it's that type of thing that is probably just around the corner. But it takes curiosity, and it takes being open to the results not going the way that you expect them to, and being able to challenge and ask questions. So another kind of similar or adjacent industry is around just chemistry. You know, chemicals and elements behave in very specific ways under specific conditions. And that means that if you understand all of that, then you can both make sense of, you can measure things and make sense of that, and deduce certain conclusions, which is especially relevant and applicable to geothermal, where quite often it is this type of situation. There's some sulfur that is coming out of the ground, and you need to sample it and understand what that means in the context of the entire system or project area. And so there's a lot of different things you can do with the chemical side of things. It's pretty amazing. So, you know, from kind of classifying rocks and minerals to also understanding the distribution and composition of the minerals and the fluids and all that, which is awesome, because then you know what you have right there. But also there's problems that still need to be solved that we've not even really begun to admit they're a question yet. So for example, carbon capture and storage, and there's kind of a starting to see a type of project that is evolving where a patch of ground wants to use geothermal energy for heat or direct use or power, but they also, in doing that, are generating their own carbon emissions, and so they want to find a way of sequestering the carbon. And so it ultimately means carbon capture and geothermal in the same project area, but how, you know, what's the geometry and how do you both extract from one unit and inject into another unit the carbon dioxide, and what does that do to the whole system, and things like that, where understanding the chemistry, well, and other things as well, but you know, chemistry is going to play a big role in that. Same thing with the what's called THMC, the thermal, hydraulic, mechanical, chemical modeling, reactive transport, what happens when injection water comes back to the surface as you know, having a different composition, what happens over time, and this whole thing. It's there's so many different elements of the whole chemistry sector. So you know, same with corrosive prediction. You don't really want to have your equipment corroding and needing to be replaced, and so how do you handle how do you predict the corrosive behavior? And then, you know, also what's in the water? What are you producing? There's a whole several projects working on pulling critical minerals from geothermal brines and looking at, you know, pulling up the geothermal brines, pulling out the minerals, re-injecting or injecting the same water back down, but with the minerals extracted from the mineral depleted same water. So the implications for kind of resource distribution, quantifying the resource, quantifying the reserve, which are all terms from the mining industry and have their own codes of certification and qualification and bankability, you know, that comes into it as well. So the as well the surface facilities and the separation facilities, you know, being able to design those so that they are built to last. You know, you wouldn't be able to do that without having somebody that understands about the chemical implications for doing stuff. So then, you know, kind of going a bit deeper into the geosphere, where the sort of, I want to say, like, bog standard geology is something that has to be learned, and there needs to be people who really are true geologists and understand all of the classic topics and subtopics within the field. You know, listed some of them here, and each of these is really their own, a whole world of things. But you know, tectonic processes, sedimentary units and the conditions under which they are formed and how to make sense of them. What are the implications for observing something adjacent to something else? You know, structural geology, fault behavior. Each one of these is has a lot of texture and expertise associated with it. And then also the kind of recognizing different phenomena and specializing in different geologic phenomena, ophelites, kimberlites, under what conditions they occur, what does it mean, all that good stuff. We definitely need to continue to pursue those topics and be able to marry them up with the other branches, other sectors. So over here, you know, I found this slide. It says key mineral exploration activities in Alberta. I didn't intend on focusing in on Alberta necessarily, Canada, but I really liked how it described or illustrated the occurrence of different geologic units, minerals, elements, features and really how important it is to understand those, to be able to identify those and understand them and understand how to constrain those and ultimately extract. So, nobody really likes talking about these extractive industries, but at the same time, they're really important. And my, I guess, main point is that each of these sectors has their own like tribe of people who really are deep into the subject and have a lot of knowledge about those that are exactly transferable to geothermal, because in these cases, well, they're transferable to geothermal when you start looking at doing geothermal outside of the normal traditional places. That's the point. So yeah, so that's that. And then my kind of favorite topic is that, and especially true with mining or the mineral industry, is that there's a whole bunch of different ways of measuring properties of rocks without touching the rocks. You use different specialist equipment to image different properties at different depths, and by varying the configuration and the type of equipment that you're using to image the anomalies or the contrasts, let's say, at depth, then you get different clues about what you have there. It used to be like back when geophysics, when kind of the hydrocarbon era, when you said geophysics, it automatically meant seismic, because that's the main tool for hydrocarbons. But with mining, they've always, because it's been kind of the poor cousin always, then a lot of different techniques have developed over time to be able to image the subsurface and get different clues about it. So this also applies to what I was referring to as the biosphere, or the shallow subsurface, because that's also where the water is, and water is such an important necessity to life. Being able to understand where water content is, and water table, and flows, fractures, and all that good stuff is it's part of the story as well. So mining geophysics and all the different cool stuff that's been invented is a really exciting frontier that to me is the most applicable, or like immediately applicable to the geothermal sector, being able to look for the ingredients, the heat, the fluid, the transport. Where are they? How can you image that? It's a powerful sector to link up to. So, and then here's it. Sunset time for the oil and gas industry. Not quite yet. So our society is still dependent on hydrocarbons. We can't really say goodbye yet, but we can look at all the things that are transferable, the different tools and techniques, and so much more. I started to list out some of the kind of specialties that the hydrocarbon sector has. And there's probably loads that I'm forgetting, but really being big into collecting and understanding data about the subsurface. Everything to do with drilling, because you're going to have to drill no matter what for geothermal, and then testing and measuring. So, thinking about just the drilling part, it used to be that there would be just one kind of drill bit, a roller cone bit, and it would just be, you just kind of use that bit to drill geothermal wells. And when you look at the oil and gas industry, they have developed a whole set of different tools and ways of approaching the drilling aspect of the subsurface in a way that's really interesting. And I don't think we've quite seen it transfer in a big way over to the geothermal industry yet. So even just starting with understanding, classifying different rocks, understanding their properties, their compressive strength, and looking at how you would define their rock strength. In this case, I'm showing kind of generalized oil and gas type rocks compared with generalized geothermal rocks. It will be a combination of both as we move away from the plate boundaries where it's hot, volcanic. So what's important is the performance, the reduction of time and cost, and all of that. You can't just put one type of solution on the table and expect it to work really well. So I love the possibility of specific tools that are thoughtful about what type of rock is expected and what does that mean for how do we interrogate it. So I borrowed this from some of my SLB colleagues in the drilling side, because I just found it really interesting that the shape of the drill bit is really designed to optimize what type of rock it's interrogating. Like this hyper drill bit, it's more of a scoop because clay and shale are soft, and it's more efficient to be able to almost scoop it compared to the stinger. That's super. You need to really hit it hard and kind of break the rock in that way. So these different shaped drill bits can be thought about and paired up with the anticipated geology in a way that ultimately allows the project to be the drilling part of the project, because we're talking about applying the drilling kind of world from oil and gas to geothermal, where you always have to drill in geothermal, but being able to apply some of the thoughtfulness into what's expected and some of the modeling tools and so forth. So here's another slide that just talks about, it kind of goes beyond the drill bits into the bottom hole assembly, and what are all the things that you can put on behind the drill bit or in the drill string, the different components, and make sure that they work. And how do you also anticipate what you're going to interrogate? And that's where this, this idea of, okay, using lessons learned, using offset wells, incorporating data from libraries that already exist about how to drill through, or what happens when you drill through different types of rock units, what works well, what doesn't work well, what's the expected behavior, that it is also able to be immediately applied. And then to take it a step further into the modeling, where you actually are modeling that specific well with the specific bit and bottom hole assembly, and to kind of determining what type of stress fields you'll encounter as you drill, and then be able to kind of loop it back around as you drill more wells and gather more data and all that. Of course, one of the reasons why this hasn't been done so much is because it's expensive, and geothermal has historically not been a very it works on a much lower magnitude of economic feasibility. So nobody has money to be kind of putting these fancy tools down the well. But at the same time, it will, the cost of drilling will come down, and we just need a bit more experience on projects that are able to apply these, well, principles and tools and techniques. In this one about the surveillance, OptiWell real-time surveillance, you know, being able to drill and feed back information to the surface at the same time, in order to determine what to do next or which way to drill when you're encountering some unwanted vein or whatever. Again, hasn't been done that much, at least to my knowledge, because of the cost. But then overall, when it comes to the process control and the operations, it really is about reducing the cost and being able to to minimize the amount of emissions that's incurred as you're drilling, and be able to do it just in a what's the most optimal way of interrogating the subsurface. That's what we have. That's what we can take from the hydrocarbon industry. And there's other, you know, I'm sure this is all like SLB info that I gleaned, but I'm sure all the other players out there are thinking about this as well. And this is also where the more we can talk to each other in different sectors and learn about this, then we'll have even more ideas, new ideas that will build upon this. In fact, this is where there's so many other sectors that are valid sectors in their own rights that are applicable to geothermal, you know, from project management, just kind of plain old project management, and how do you get different people to work together and meet deliverables and everyone's happy and you do it within budget. That type of thing can come from other sectors. And utility, I'm not sure what I meant by that, but surface facilities, whole world of kind of being able to optimize the equipment that you install on the surface and have it tuned to what you're expecting to produce from the subsurface. That's, you can't just plonk a generator down and expect it to work. It has to be tuned. And so this bridging or marrying up of the subsurface with the surface, bringing in the whole engineering component, finance, social, environmental, and back to the communicating and education. I think that in order for any of these different sectors to be applied to geothermal projects and be able to move the needle, it takes a different attitude, which is, you know, difficult to convey maybe in a slide, but it is more about curiosity and asking, like simplifying and asking questions about how this works in this other sector in order to, you know, have different ideas that allow you to apply it to geothermal. So I see geothermal sector business as really being this kind of best of breed energy source, and I just think it's beautiful. But when you, and that's just for geothermal, and then it's kind of taken to another level when you start to think about the geothermal plus or geothermal hybrid. You know, geothermal can play really nice with other technologies. This particular example in Nevada is cool because it combines two types of solar PV, and also thermal solar, concentrated solar power. They all come together in this elegantly engineered way, and it's feeding into the power grid. So you can kind of see the solar panels all here. And then this is the geothermal part. I think this picture was taken actually before the solar thermal component was added on. But I think this is what we're going to see a lot of going forward, is different types of energy needing to come together. Here's just another view of that previous slide, kind of rotated 90, and you can see the small footprint it takes up compared to the masses of solar panels. So, but this concept over here is quite important because it's the hybridness of this project that allows both the overall temperature to boost. So here you see the solar in megawatts, you know, obviously it doesn't produce anything in the dark. And then when it's just geothermal, it's, you know, going like this. So combined, you not only boost the temperature, but you also allow the combined power to be balanced. And so this is really what I would expect to see more of. And okay, in this case, it's Nevada and it's a special area anyway, but it's combinations like this are possible all over the place. So this is another way in which we can see different things coming together. I love this example. It's in England, and it's just this village of 300 houses and 2 churches and a pub and a school that has put in their own little energy center with these boreholes and solar farm, and they have backup generators. So it's not completely 100% renewable energy, but they also have designed it to be able to incorporate new technology as and when. So this also kind of points to the digitization and AI kind of increase use. Like, it requires serious energy, and these server farms is another type of application that needs support, that can be supported by geothermal or by combined things. Microgrids, this is where we really see, I mean, getting into the whole energy security and microgrids and all that. Geothermal has a big part to play there. So just to wrap up, you know, I really believe that it's an interesting moment now. We need all hands on deck, and we need to link up these knowledge silos in order to both progress the geothermal sector itself, but also be able to interface with other energy sources, both renewable energy sources and also non-renewable. You know, oil and gas is not going away yet. We need to be able to play together. And so as kind of young people starting your careers, or, you know, early in your careers, I think there's a huge potential for innovation. And to me, it's really about, the need is to have an attitude of learning and curiosity, and how can you find out more about other, you know, kind of hone your craft in your silo, and then be able to link up with other silos. So that's it for me. I guess any 5 minutes for questions, I guess.
Thanks a lot, Lisl, for your very interesting presentation indeed. And so if anybody has any questions, please feel free. You can unmute yourself, ask directly, or you can also write in the chat. I don't see anything in chat. And in the meantime, when participants are thinking, on this synergy slide, Lisl, I just noticed that in the daytime, the geothermal was actually dropping. Was it like something site specific, or I don't expect it to drop in the daytime,
Yeah,
or
I'm not
I
sure.
miss.
I don't know. I don't know. It's a
Okay.
good observation.
Okay. And then another thing which I was wondering was that um, on the implementation, like because we talked in terms of decarbonization and then on sustainability.
Mm.
So on both of them. So what are the key requirements when we are looking at developing a site for as a sustainable site? Like, is it how deep we have to drill, or is it such and such gradient has to exist such that it becomes sustainable? How do we determine it?
Yeah, that's another interesting question. I think that, in fact, it's almost asking the wrong question, or I think what we need to do is better understand what we need. This is because geothermal doesn't travel that well, right? So it's available all over the world, but you need to use it where where you're accessing it, where you're interrogating the subsurface. So it seems like you'll have things will kind of come together more easily when you can ask yourself or the community or the end user who is right there what is needed. And this is where the discussions with industry come in, decarbonizing industrial processes where they know what they need to run their factory or build their car or whatever. What part of the process can be decarbonized? What do they need kind of energy wise for that? And then be able to that generates a whole kind of specific line of questioning. Didn't
Okay.
really answer your
Okay.
question, but hope that
No,
makes
yeah,
sense.
yeah, thanks. I see Loris has raised hand. Please go ahead.
Yes, yes. So thank you for the presentation. Just more of a comment on the geothermal curve than an actual question. The thing is that having a drop in the base load of the geothermal unit might have to do with here what we call, I don't know if I'm translating it well, what we call the return on energy, which is the amount of joules you will put in the system to recover a superior amount of joules. So probably on this site, the thing is that the solar unit has a better return on energy, which is you need to input less joules to recover the same amount of joules, and probably the geothermal unit is designed for a certain range of power, but is at some point in the day the solar is actually more efficient than the geothermal, so they downscale a little bit the geothermal unit. And this, just to follow the comments and probably the discussion, it's that you mentioned AI and all the other sectors that need to be at least reached for better synchronization of the energy production. There are a lot of initiatives in that sense, and also, and probably a lot on the energy distributors, which now have a lot of data. At least here in France, we do know that because they changed all the energy counters for private individuals and companies, and this is some data sets that are definitely of a great use in terms of AI and unit designing, because you have this idea of the return on energy, but you have also this idea of scale versus energy loss on the grid, which is in that sense, you have to have a thought about what do you design, but where also you design it, and you don't sometimes need to produce the most amount of energy. You need to produce the right amount of energy, which is sometimes counterintuitive. But when you think of energy loss on the grid, this is definitely something that you need to think in terms of scale. So not really a question, but just a comment for the discussion.
Great comments. Thank you, Loris.
Yeah, thanks a lot, Loris. Yeah. Are there any other questions? We have almost reached at the end of our discussion for today and presentation. Well, in case if there are no further questions, then I would like to thank again to Lisl for accepting and presenting. I'm pretty sure that in future we will have more chances to interact and discuss it even further from what knowledge I have got, at least on my end. And finally, I would like to thank all the participants again for today for joining us. Please be in touch with the young professional community and our upcoming webinar series on such interesting topics. And I wish you all a very great day. Thank you.
Thank you. Bye.
Thank you so
Bye-bye.
much. Thank you. Bye bye.